This is a partial synopsis of some of the pollution and the assignment that you'll be doing at the end of looking at these. There are four major types of air pollution that we have to deal with: acid rain, global warming, particulates, and ozone, which actually has one effect in the lower atmosphere and there's another effect in the upper atmosphere. So we'll talk about both of those when we get there. This is the reading and the pictures that you will see um, inside of this particular folder. I want to look at acid rain first. And there are three possibilities of gases that are possible contributors to acid rain. They are all non-metal oxides. And if you remember, a few weeks ago we looked at types of compounds, and one type of compound were the oxides. And what happens with the non-metal oxides, like carbon dioxide, when you bubble them through water, they actually go through somewhat of an equilibrium, or they can dissolve in water. And what they form is a compound that starts with H, which makes it an acid. Now, carbon dioxide forms just carbonic acid, and carbonic acid is what we drink in soda pop, so that doesn't seem too bad. That's actually a weak acid. Carbon dioxide is formed from combustion of any hydrocarbons. But there are two other nonmetal gases that are produced. One is nitrogen oxides. And you have to think about your car. Your car is burning fuels. The products of that combustion is carbon dioxide and water. Fuels are hydrocarbons, CXHY. X and Y can be a variety of numbers. You add oxygen to that and you burn it, you make carbon dioxide and water. But in your car, you're not using pure oxygen, you're using air. And air is 80% approximately nitrogen gas. So in the process of going through your car, coming out the tailpipe, the nitrogen combines with a variety of things, and there are nitrogen oxides produced. And there are a variety of nitrogen oxides: NO2, NO, N2O, N2O3, and actually they just combine them all together and call them NOx, some ratio between nitrogen and oxygen. Well, ultimately, and the easiest one to do this for is nitrogen dioxide, because it actually works out. The rest of them have messier equations. But if you combine nitrogen dioxide with water, you're going to get nitric acid. And nitric acid is a strong acid. The other possibility is the sulfur dioxides. And when sulfur dioxides combine with water, you can actually have a couple step process here. We can also have sulfur trioxides. You get sulfuric acid. And this is also a strong acid. Both of these are strong acids. The one we're actually worried the most about is the sulfur dioxide. And we're worried the most about that because it is a strong acid and it is highly soluble in water. So if you bubble sulfur dioxide in water, you ultimately end up with sulfuric acid. This is battery acid, so think about this. Not great. This means that if you breathe sulfur dioxide and it combines with the water in your lungs, you're actually producing battery acid in your lungs. So these are the main gases that are involved in acid rain, and the sulfur dioxide and sulfur trioxides are the most important and contribute the most to it. Sulfur tends to be present in coal, and it tends to be present in oil a little bit, and it's hard to get it all out. At truck stops, a lot of the trucks have to buy low sulfur diesel fuel, and a lot of them are required to use that. Here are some pictures of things that acid rain can do. This is a sculpture, and a lot of these sculptures are made of marble. Marble is calcium carbonate, and when you add an acid, and I'll just use HCl as an example, to that, you actually form calcium chloride and carbonic acid. And I'm going to balance that for you. Calcium chloride happens to be soluble, whereas calcium carbonate, marble, is insoluble. So as the acid, it basically eats away that marble. And in fact, if you take geology, one of the ways you'll test for limestone and marble will be to use hydrochloric acid and see if it bubbles, because you actually form carbon dioxide and water out of the carbonic acid. Now, because there is such a problem with sulfur dioxide, you will see that most of the large power plants, and this is a picture of Marshall Steam Station, which is near I-77 near Mooresville, and I don't know if I spelled that right. And this is the new scrubber that has been added within the last couple of years. Originally there were 4 smokestacks, and there they are. And notice there was nothing coming out of those 4 smokestacks. All of the carbon dioxide and sulfur dioxides are being diverted over to the second stack, and they are actually combining that with calcium carbonate, and they're ultimately forming calcium sulfate, which is gypsum. Now they're still putting out carbon dioxide. They're not stopping that. That hasn't happened. But mostly this is now water, steam, and carbon dioxide in the smoke that you see. I also noticed that if you drive on I-26 towards Asheville, as you get closer to Asheville, you can see one of these stacks sticking up. Originally they were costing in the order of $250 to $500 million to build one of these scrubbers. So this is acid rain.